Hello dear students, welcome back to our channel BTech Mathematics 2.0. In this channel we are discussing higher mathematics for BTech BSc students. We started calculus in the previous lecture, and in the previous lecture we introduced the concept of partial derivatives, and now we will do some questions related to partial derivatives in this lecture. Okay, so we'll move on to the questions. Question number 1: find the first and second order partial derivatives of z is equal to x cube plus y cube minus 3axy. Okay, we need to find the first order and second order partial derivatives. For that, first we'll take its first derivative with respect to x, that is dou z by dou x, which is equal to differentiating this expression with respect to x. While differentiating with respect to x, we will treat y as a constant. Therefore, a derivative of x cube is 3x square with respect to x, and y cube is a constant with respect to x. Therefore, its derivative will be 0, minus here 3ay is a constant, minus 3ay is a constant, and x, the derivative of x is 1. Therefore, we write like this. This is 3x square minus 3ay. This is dou z by dou x. Sometimes we will call, or we will denote dou z by dou x as p. The symbol p. P will be used. Small letter p will be used to denote dou z by dou x. Now the second first order derivative, that is dou z by dou y, is differentiating this expression with respect to y. X cube is a constant, therefore its derivative will be 0, plus derivative of y cube with respect to y is 3y square, minus 3ax is a constant, 3ax into derivative of y is 1. Therefore this will be 3y square minus 3ax. We will call, or we will denote this dou z by dou y as small q. Okay, p and q. Now these are the first order partial derivatives, and we'll move on to the second order partial derivatives, that is dou square z by dou x square. That is, we need to differentiate dou by dou x of dou z by dou x. That is equal to dou by dou x of dou z by dou x is 3x square minus 3ay, and its derivative with respect to x is 3 into derivative of x square is 2x. And here there is no x, therefore it will be a constant, therefore its derivative is 0. Now this is equal to 6x. Dou square z by dou x square is called, or it is denoted by r. Okay, now we will find dou square z by dou y square. That is equal to dou by dou y of dou z by dou y. Okay, that is equal to dou by dou y of dou z by dou y is 3y square minus 3ax. This is equal to differentiated with respect to x, 3 into derivative of y square is with respect to y, actually derivative of y square is 2y, and 3ax is a constant regarding y, therefore this will be 6y. Okay, this is the second order derivative, and we will denote this dou square z by dou y square as t. Okay, now we have one more derivative, that is dou square z by dou x dou y. Okay, that is dou by dou x of dou z by dou y. That is dou by dou x of dou z by dou y is dou z by dou y is 3y square minus 3ax. Now we will write this as, we will differentiate it with respect to x. Therefore 3y square is 0. Derivative 3y square with respect to x is 0, minus 3a into x. Derivative of x is 1. Therefore this is minus 3a. Okay, this is dou square z by dou x dou y, and similarly we can write dou square z by dou y dou x. This is equal to dou by dou y of dou z by dou x. That is equal to dou by dou y of dou z by dou x is 3x square minus 3ay, and its derivative with respect to y is 0 minus 3a. it is again minus 3a. Therefore, from this two mixed partial derivatives, we can write dou square z by dou x dou y is same as dou square z by dou y dou x. Okay, this is the first question. Okay, now we'll move on to the second one. Question number 2. This is a question from KTU, first year KTU examination. Okay, show that dou square z by dou x dou y is equal to dou square z by dou y dou x. That is, or otherwise we'll ask, it will be asked like this. Show that the mixed first second order partial derivatives are equal. Here given functions given like this, z is equal to x square y plus 5y cube. Z is equal to x square y plus 5y cube. For that, first we will differentiate it with respect to x. Dou z by dou x. This is equal to 2xy. Okay, derivative of 5y cube with respect to x is 0. And we will differentiate it again with respect to y. That is dou square z by dou y dou x, which is dou by dou y of dou z by dou x. That is equal to dou by dou y of dou z by dou x is 2xy. And its derivative with respect to x, sorry, with respect to y is 2x. Okay. Now this is dou square z by dou y dou x. Now we will differentiate the given function with respect to y. Dou z by dou y, that is equal to x square plus 15y square. This the derivative with respect to y. Now we will differentiate this again with respect to x. Dou square z by dou x dou y. That is same as dou by dou x of dou z by dou y. That is equal to dou by dou z of, sorry, dou by dou x of dou z by dou y is x square plus 15y square. Okay, its derivative with respect to x is 2x again. Okay, therefore we can have the result dou square z by dou x dou y is same as dou square z by dou y dou x. Mixed second order partial derivatives are equal. Okay, this is the second question, and we'll move on to the third one. If u equal to y by z plus z by x, we need to show that x into dou u by dou x plus y into dou u by dou y plus z into dou u by dou z is 0. Here the function is given like this: u is equal to some function of some x, y and z. It's a three variable function. Therefore we have three partial first order partial derivatives: dou u by dou x, dou u by dou y, dou u by dou z. Okay, now what is dou u by dou x? This is equal to, with respect to x, y by z. Y and z are independent of x, therefore its derivative will be 0 plus z into, what about 1 by x? Its derivative is minus 1 by x square. Therefore this dou u by dou x is minus z by x square. Okay, again we will differentiate it with respect to y. That is dou u by dou y. That is equal to, here y by z, 1 by z is a constant, then 1 by z into y, derivative of y is 1. Therefore 1 by z will be the answer for dou u by dou y. And this z by x doesn't contains any y, therefore this is dou u by dou y. This is dou u by dou x. Now what about dou u by dou z? Dou u by dou z, that is equal to, in the two terms we have z, isn't it? So for y into derivative of 1 by z is minus 1 by z square plus 1 by x is a constant into derivative of z is 1. Therefore we have minus y by z square plus 1 by x as dou u by dou z. Okay, now we will substitute all these derivatives in the LHS of this equation. That is, we have to prove. Okay, therefore LHS is x into dou u by dou x plus y into dou u by dou y plus z into dou u by dou z. This is equal to x into dou u by dou x is minus z by x square, okay, plus y into dou u by dou y is 1 by z plus z into dou u by dou z is minus y by z square plus 1 by x. Now this is equal to, we can cancel these two, uh, 1x from this expression. Therefore, it is minus z by x plus y by z. Multiply with this z, we will get minus y by z and plus z by x. Now we can cancel these functions. Y by z minus y by z minus z by x plus z by x. This will be 0. Therefore, this is our RHS, isn't it? This is question number 3. Then we will move on to question number 4. If z is equal to f of x plus ct plus g of x minus ct, prove that dou square z by dou t square is equal to c square into dou square z by dou x square. Here, the function z is given in this format. It is a function of x ante plus a function of x ante. Okay. Therefore, we need to write dou z by dou t first. We need to find dou z by dou t. That is equal to, we don't know what is the function f of x plus ct. Therefore, we will write simply f dash of x plus ct into derivative of x plus ct with respect to t. Derivative of x is 0 and derivative of ct is c. Okay. Plus, again, derivative of g is, we don't know what is g is. Therefore, g dash of x minus ct into derivative of x minus ct with respect to t is x. Derivative of x is 0 and minus c into derivative of t is 1. Therefore, we can have this dou z by dou t as c f dash of x plus ct minus c g dash of x minus ct. Okay, now we will take its second derivative, dou square z by dou t square. That is again c into constant into derivative of f dash of x plus ct is f double dash of x plus ct into derivative of x plus ct with respect to t is c, isn't it? Minus c into derivative of g dash is g double dash of x minus ct into derivative of x minus ct with respect to t is minus c. Therefore, we can write this as c square into f double dash of x plus ct plus c square into g double dash of x minus ct. Therefore, we'll take c square common outside, c square into f double dash of x plus ct plus g double dash of x minus ct. Okay, we'll take this as equation number 1. Okay, therefore we have dou square z by dou t square. Okay, now what about dou square z by dou x square? For that, we'll take dou z by dou x first. Dou z by dou x is, again, we don't know what is f. Therefore, its derivative is f dash of x plus ct into derivative of x plus ct with respect to x is 1. Derivative of x is 1 and derivative of ct with respect to x is 0. Plus derivative of g is g dash of x minus ct into 1 again. Okay. Therefore, this is f dash of x plus ct plus g dash of x minus ct. Okay. Then its second derivative is dou square z by dou x square is, again we will differentiate this like similar way, f double dash of x plus ct into 1 plus g double dash of x minus et into 1. Okay, this is equation number 2. Therefore, we can have this. We can substitute this. What about this dou square z by dou t square? Dou square z by dou t square is c square into f double dash of x plus ct plus g double dash of x minus ct. Now we will rewrite this as c square into, what is this? From the second equation, we can have it as dou square z by dou x square. Dou square z by dou x square. Therefore, we have proved that dou square z by dou t square is equal to c square into dou square z by dou x square. Okay, we will move on to the next question, question number 5. This will be the last question in this lecture. u is given as x cube plus y cube by x minus y. We need to find dou u by dou x plus dou u by dou y. That is, first we need to find dou u by dou x. We will use quotient rule here. It is x minus y into derivative of x cube plus y cube with respect to x is 3x square minus x cube plus y cube into derivative of denominator is 1 divided by x minus y the whole square. This is equal to 3x cube minus 3x square y minus x cube minus y cube divided by x minus y the whole square. This is equal to 3x cube minus x cube is 2x cube minus 3x square y minus y cube divided by x minus y the whole square. Okay, now dou u by dou y, that is equal to, again we will use quotient rule, x minus y into 3y square minus x cube plus y cube into derivative of x minus y is minus 1 divided by x minus y the whole square. This is equal to 3xy square minus 3y cube plus x cube plus y cube divided by x minus y the whole square. This is equal to, we can rewrite this as 3xy square minus 2y cube plus x cube divided by x minus y the whole square. Now we will add these two derivatives, dou u by dou x plus dou u by dou y. This is equal to, we can take the common denominator x minus y the whole square, and we will add the numerators 2x cube minus 3x square y minus y cube plus 3xy square minus 2y cube plus x cube. Okay, we will rewrite this as 2x cube plus x cube is 3x cube and minus y cube minus 2y cube is minus 3y cube, and we have minus 3x square y plus 3x y square divided by x minus y the whole square. Okay, this will be the answer. If you want to simplify this, you can also simplify, or otherwise we will leave it here. Okay, this is the fifth question. I think this is the end of this lecture, and we will discuss more questions in the coming lectures. Okay, thank you. Bye bye.